the Lagrange interpolation and the Newton interpolation respectively. Okay, so two interpolation method to find a polynomial satisfying the following interpolation conditions. Now we obtain three conditions. f0 equal to 0, f1 equal to 1, f2 equal to 0. Right? Okay, so now we need to use two methods for the Lagrange interpolation. Okay, we know the Lagrange interpolation means P, because we have 3 points, so it should be P2, right? P2x equal to fx0 multiply L0x plus fx1 multiply L1x, right? And plus fx2 multiply x2 L2x, right? So L0, L1, and L2 are 3 Lagrange interpolation bases. It's okay? Now here, because f0 is 0, f2 is 0, actually we only have one term, right? So we only need to check to write L1. Okay, L1. L1, okay, you should remember how to write the basis, right? So it should be the ratio, the denominator is factors x minus other nodes, right? So now you should remember L1, okay, is corresponding to the node. We have 3 nodes, right? x0 equal to 0, x1 equal to 1, x2 equal to 2, right? Okay, so for L1, it should be x minus other nodes. So other nodes are 0 and 2. So minus x minus 0 multiply x minus 2 divided by, replace x by node, okay, x1. So 1 minus 0, 1 minus 2. Okay, so it is just minus x multiply x minus 2, because this is 1, this is minus 1. Clear? So we obtain the basic function L1. Okay, so Px or P2x. Now we only have this term. So f1 is 1. So 1 multiply this formula, function, right? Basics. Okay, so the answer is minus x squared plus twice 2 multiply x. It's okay? So this is Lagrange interpolation. Of course, you can check when x equal to 0, 0. When x equal to 2, okay, minus 4 plus 4, 0, right? When x equal to 1, minus 1 plus 2 is 1. Okay, check. We obtain the correct answer, right? Okay, so this is the result by Lagrange interpolation. Now, we use Newton interpolation. For Newton interpolation, we need to use this table of divided difference. It's okay? So now 3 nodes, 0, 1, 2, and 3 function values, 0, 1, 0, right? Okay, first divided difference. Now we use 1 minus 0 divided by 1 minus 0, so it is 1, right? It's okay? And next we use 0 minus 1 divided by 2 minus 1. Okay, so it is minus 1. Clear? Minus 1. Okay, next compute the second divided difference. So we need to use this number minus 1 minus this number. So minus 1 divided by, okay, 2 minus 0. You should remember 2 minus 0. It's okay? So that means minus 1. Clear? Okay, now we choose the 3 diagonal elements as the coefficient. So the Px, the polynomial, should be this number, 0. Okay, so I write the formula for you. P2x equal to fx0. Remember, it's okay? Plus, okay, the first dd, fx0, x1, multiply x minus x0. So here, this number is 1. So 1, okay, 1 multiply x minus 0, right? And plus the second dd multiply x minus x0, x minus x1. Clear? So it is minus 1. So here is minus 1, right? Okay. Multiply x minus x0, multiply x minus x minus x1. X minus 1. Clear? Because x1 equal to 1. Okay. So of course you will obtain the same answer as Lagrange interpolation. Okay. If you obtain different results, that means at least one result is not correct. Clear? Okay, so now we obtain the polynomials satisfying the interpolation conditions by Lagrange interpolation method or and the Newton interpolation method. Clear? Okay, now next question. Okay, we need to find the degree of accuracy of the following numerical quadrature. Okay, so you should understand what is the definition of degree of accuracy. That means we need to check how many monomials can be used to compute the integrals exactly by this formula. Clear? So so that means we need to check. Okay, so now first one we check the function when f equal to 1, right? When f equal to 1, right here, then the exact integral equal to 2, right? Of course, very clear, right? Because f is 1. And now you see the numerical quadrature f minus 1 plus f1. Okay, that means 1 plus 1. Of course, it is 2. Now we check for f equal to 1. It is correct, right? And now let's check for f equal to x. X dx, we know it should be 0, right? Because this is order function in the symmetric interval, so its integral is 0. Of course, you can use Newton-Leibniz formula. You will also obtain 0. Okay, and now let's check by the numerical. Okay, so when f equal to x, then the function value at minus 1 is just minus 1, right? Plus the function value at 1, okay, again 0, right? The summation is 0. Okay, so that means this quadrature is also satisfied for f equal to x, right? Now let's check x squared. Then minus 1x squared dx, okay, by the Newton-Leibniz formula, it should be 1 over 3 x cubic, right? It's a primitive function. And minus 1, 1, so it should be 1 minus minus 1, so it is 2 over 3, right? It's okay. So the exact integral is 2 over 3. However, if we check the numerical result, a numerical quadrature for f equal to x squared, then minus 1 squared is 1, plus 1 squared is 2. Okay, so you see the numerical quadrature is 2. 2 is not 2 over 3. Now you see for x squared, the exact integral is not same as the numerical quadrature. So we know the degree of accuracy is just 1. Clear? By the definition of degree of accuracy. Okay, last question, okay? For the data xi, yi, I from 1, 2 to m, okay? We need to ask you to deduce the normal equations for the least square approximation. Okay, now I ask you to practice by the quadratic polynomial. In the lectures, okay, I taught you to deduce by deduce for to approximate the linear function. But now I ask you to practice for the quadratic polynomial. Okay, so actually the idea is same. So you should understand the least square. What means the least square approximation? Here, I don't give you the specific numbers. I just use the symbol. Okay, xi, yi. That means I help you to practice the formula, right? Okay, so you should understand the least square means we need to compute the error, right? The error for each data point, fxi minus yi. It's okay? So here, fx is a plus bx plus cx square. Clear? Okay, so fxi minus yi is the data points, right? Data values. Okay, and compute square. Okay, then compute the summation I from 1 here, I from 1 to m. So the summation of errors. Okay, and fxi equal to a plus bxi plus cxi square minus yi, then compute square summation. This is okay because xi are given here, so we can consider this right term as a function, new function divided by e, right? Corresponding to the 3 coefficients a, b, c. Because we need to determine the 3 coefficients a, b, c, right? So we consider this summation as a new function of 3 variables a, b, c. Clear? And because we need to find the least value, a minimum value, so we need to compute its gradient, right? So we need to compute gradient partial e, partial a, partial e, partial b, partial e, partial c. Let's then be 0. Then we can obtain the normal equations. Clear? Okay, so let's practice. What is partial e, partial a? Okay, partial e, here e is this, so we need a computer. Okay, summation I from 1 to m, right? Okay, because this is square, right? So 2 times a plus bxi plus cxi square minus yi, and don't forget, because we compute the derivative, partial derivative on a, so okay, this factor, the term derivative on a is 1, so it is 1, right? Partial e, partial a equal to this formula. Clear? Okay, then we need to let it equal to 0. Okay, so this is the first equation. And partial e, partial b. Okay, summation I from 1 to m. Again, 2 times a plus bxi plus cxi square minus yi, and multiply the partial derivative on b. Okay, so the derivative should be xi, so multiply xi. Partial e, partial b equal to 0, the second equation. Okay, and similarly, partial e, partial c, it should be sigma I from 1 to m, 2 times again a plus bxi plus cxi square minus yi, multiply, okay, partial derivative on c, so we have xi square. It's okay for you? So this is the third equation, partial e, partial c. In our lecture, we only consider the linear case, then we only have a and b. But now we add one more term, so we need partial e, partial c like this. Clear? Okay, so actually, what is normal equation? This is just the normal equation. Okay, so the final step is to write this linear system of A, B, C as unknowns in the matrix form. Clear? Into the matrix form. So, firstly, because the right term just 0, so we can divide 2, 2, 2. It's okay? And the first equation we write, okay? We write the first equation by sigma I from 1 to m. Okay, A, we take out, okay, so we can move A outside the summation, so it should be summation of 1, right? Multiply A, clear? Plus second term, so we can take out B outside the summation, so this is I from 1 to m, summation of xi, it's okay? Multiply B. Clear? Multiply B. And this term plus sigma I from 1 to m xi square, right? Multiply C. Clear? Multiply C. And this term minus, take out, so minus summation of I from 1 to m of yi is okay? Equal to 0. This equation equal to 0. Okay, so we write this equation in the first row. So you see A, B, C, A, B, C. The three coefficients should be sigma 1, right? Sigma xi square. Okay, right term, move this term to the right side, so sigma yi. Clear? The first equation. Clear? Partial E, partial A. Clear? Okay, let's consider partial E, partial B. So similarly, but don't forget we need to multiply xi inside 1, 2, 3, 4 terms. Okay, so first term for A, multiply xi, so we need I from 1 to m, summation of xi, multiply A. Clear? Multiply A. Okay, for B, summation I from 1 to m xi square, because xi multiply xi square, then take out B, right? And I from 1 to m xi here, 2 square multiply xi cubic. Clear? Multiply C. And minus yi multiply xi. So sigma I from 1 to m xi multiply yi equal to 0. Clear? This is the second equation. So A, B, C, A, B, C. Then three coefficients. Sigma xi here, sigma xi square here, sigma xi cubic here, right? Right term, now you see, move this term to the right side, sigma xi yi. Clear? Okay, last equation, partial E, partial C. So clearly, so sigma I from 1 to m. So here, don't forget, multiply xi square to each term. So xi square multiply A, right? Plus sigma I from 1 to m. So xi cubic is okay? Because already one time power and square, so cubic is okay? Multiply B. Plus sigma I from 1 to m xi, okay? Square, okay? Power 4. Clear? Multiply C. Minus sigma I from 1 to m xi square multiply yi. Okay, equal to 0. Okay, again, now you see A, B, C, A, B, C. So three numbers, coefficients. Now you see xi square, xi cubic, xi4. Okay, now you see last term xi square yi. Clear? We just write these three equations into the linear system, into the matrix form. So we obtain this is the normal equation. Okay, this is for the general case. Of course, if you are given some specific numbers, you only need to substitute the numbers. You will obtain the linear system 3 by 3 matrix. Then you solve it, you will obtain the answer. Clear? Okay, that's all for the exercises. I hope you can understand totally. Okay, if you cannot obtain correct answer in your homework, okay, that's okay. But I ask you to practice, okay, by yourself again. Follow my explanation. Okay.